Hi everyone, I'm Pinaki and I shall be presenting our paper CceneTrilogy on human scene sketch and its complementarity with photo and text. Can you describe this scene image to me? As humans, we can use text or write a textual description for this scene. A bench is there in front of a house. Or maybe it doesn't capture the essence of the scene. Maybe a sketch can do a better job. Or maybe both. Our paper is about this optionality, the option given to a user to either use text or sketch or both as input modality for downstream tasks. To achieve this optionality, we basically disentangle the information in each modality into two components, a modality specific and a modality agnostic information. We will talk more about the need of this disentanglement in the next few slides. Beyond being curious to verify our intuition, we conduct two studies to empirically show the effect of using sketch versus text for image retrieval. The red line is for sketch-based image retrieval and the blue line is for text-based image retrieval. The plots being continuous, the x-axis is basically 3000 random samples. Note, sometimes you get a better retrieval rank when using sketch, the red line, whereas at other times, text performs better. Okay, so previous study was on using sketch or text for image retrieval. In this slide, we want to highlight the salient regions of the photo in the left. To express which regions are salient, you have three options. Use text tags that are sequence of tags such as det, noun, verb, etc. The second option is to simply draw a mouse trace on the photo as shown by the red scribble over the image in third column. And then there is sketch. The sketch clearly depicts the key elements, two horses and a tree behind them. The table shows here a more quantitative study of this saliency, that is, using text tags, mouse trace, or sketch as guidance for saliency. We design an image captioning model which in principle should focus on the relevant or salient regions. As expected, text tags provide the least saliency, then mouse trace and sketch are somewhat competitive. You see, the point we want to emphasize here is not that sketch is always the best, but in the bigger picture, different modalities are useful at different times, and a user should always have this option to seamlessly move from one modality to another, or better, use a combination of the possible input modalities. So let's understand this information disentanglement in each modality. Modality-specific information in a modality such as text can be grammatical construct, which has no meaning or usefulness in other modalities. For a sketch, the modality-specific components could be drawing style, and for text, this could be less relevant texture information. You see, although this modality-specific information has no use for cross-modal tasks such as going from sketch to photo, it is highly important to reconstruct that specific modality. That is, sketch drawing style may not have much use for sketch to photo generation, but the same style information is crucial to generate or reconstruct the sketch itself. Going a bit more technical, this disentanglement is achieved using a conditional invertible neural network. In a typical neural network, information flows from the input data to the output logits. In an invertible neural network, the information can flow either ways, that is, FSPK to eta during training, or the reverse path, that is, eta to FSPK. In a sense, an invertible neural network is a bijective mapping function. Conditional invertible neural network takes a step further by adding a conditional vector. Intuitively, our conditional invertible neural network takes the modality specific vector and then conditions on the modality agnostic such that it removes all the modality agnostic components and learns a prior distribution eta that only captures the modality specific information such as drawing styles for sketch or grammatical knowledge for text. In the inference path denoted by the blue arrow, We sample this modality specific eta, say grammatical knowledge, and combine the modality agnostic information such as horse standing in front of a tree and predict the grammatical correct sentence describing the horse. Our conditional invertible neural network basically takes the form of an information bottleneck equation where we increase the mutual information among the modality agnostic vectors from different modalities and simultaneously try to minimize the mutual information among the modality specific and modality agnostic vectors in each modality. Previously, we showed how information disentanglement helps optionality in input modality, that is, text or sketch or both. Now we show how the same disentanglement technique also helps optionality across tasks. Instead of designing a separate task-specific network for one for image retrieval and another for captioning, mixing and matching this image modality agnostic and modality specific components can help the same network generalize across two very different tasks. One is retrieval, that is discriminative, which focuses only on the most important or relevant stuff and filters minor information like drawing styles when retrieving an image. The second is a generative that explicitly relies on those minor details such as drawing style for a good sketch generation. We present a detailed view of how our method mixes and matches the modality agnostic and modality specific components to perform multitude of tasks. Finally, we show some qualitative results on sketch plus text-based image retrieval and some quantitative results. Note, while our baselines are a separate model is trained for each table or task, our proposed method is one generalized model trained once using a disentanglement approach and is competitive and sometimes outperforming baselines on all these retrieval tasks. Here we show qualitative results on our new setup subjective captioning. Unlike image captioning, where the model focuses on the man in red jacket, our sketch can provide additional saliency such as a man flying a kite. The sketch along with the input image can modify the predicted captioning to better align with human saliency. We show some more qualitative results and some quantitative captioning results. See our paper for more details by scanning the QR code or going to pinaki.c/SceneTrilogy. Thank you for your time. Have a nice day.